Now let's talk about the problems from worksheet 512. And these are still non-calculator, but you look at them and you think, well, these look different, but they look a little bit like the stuff, some of the stuff that we just had on the last test when we did the triangle problems with the identities test. And well, you know what? That's what this turns out to be. Because you look at this and you say, wait a second, that's not unit circle. I thought all this stuff was going to be unit circled. Well, that's the problem. When we did these problems, you looked at all these values and said, hey, those are unit circle. I know what to do with those. All those are unit circle. I know what angle that is. I know what angle goes with that value. I know what angle goes with that value. Whereas over here, you're like, uh-oh, I don't know what angle goes with that. So that's what we have to do. We have to say, well, if I don't know what angle goes with that, how am I supposed to find its tangent? Well, that's why these are triangle problems. These become triangle problems. Because every one of these problems, we're going to have to draw a triangle. And by the way, at least one triangle. So like for this guy here, you're going to say, when does sine, what angle has a sine of -5/13? Heck, if I know, I don't know what angle has a sine of -5/13, but I do know that inverse sine is negative in the fourth quadrant. So I know that my angle is going to be here in the fourth quadrant. So let me see, that'd be -5, that'd be 13. So my missing side is 12. Nice Pythagorean triple. So the tangent would be -5/12. Okay, no big deal. Unfortunately, when you start going through these problems, you're going to notice that some of these are not going to be Pythagorean triples. Some of these won't be Pythagorean triples. Like on this one, you're going to say, oh, arc cotan is positive. Well, anytime the inverse is positive, you know you're in the first quadrant. That makes it nice and easy. Positive always goes first quadrant. So there's my angle. So cotan, that'd be 4, 5. Uh-oh. So this is going to be 4 squared plus 5 squared, unfortunately, is 41. So that ends up being the square root of 41. So who's the secant of this angle? Well, the secant would be hypotenuse over adjacent. So root 41/4. This guy here, oh, bummer, it's not a Pythagorean triple. And it's negative. Inverse cosine of a negative. Let me see. Oh, that was second quadrant. Cosine was one of those, the negatives go into the second quadrant. So you say inverse cosine of a negative. So here's my angle. So let me see. That would be -1 and 2. So when I do the Pythagorean theorem, what do we get here? 4 minus 1. So that's going to be root 3. And I know you're thinking, hey, this is 30, 60, 90. I know it's 30, 60, 90. I was just looking for nice, easy numbers. But then you still got to say, what's the cosecant of this guy? Well, the cosecant would be 2/√3. So we end up with 2√3/3. Okay. So we had to draw a triangle on all those. And like I said, we got to watch out. These guys are not always going to be Pythagorean triples. Okay, we've done problems similar to this. We did problems similar to this back in the identity unit, because what it looks like is, it looks like sine of, and remember, when we see inverse trig, we know that means angle. So this is sine of angle minus angle. So this right here is really just sine of x minus y, which we know is sine x cosine y minus sine y cosine x. Okay. And we're going to give you the formulas. So don't panic. We're going to give you the formulas. But same routine, bummer. Let me see. Inverse tan is negative. So that's going to be fourth quadrant. So I have to draw fourth quadrant angle. Inverse tan is negative. So that's going to be my x. I know it didn't have a letter there, so I'm just going to call it x. I'm going to call the first one x. I'm going to call the second one y. So let me see, tangent. So that'd be -3, 4. So the missing side is 5. Cosine's positive. Inverse cosine's positive. So positive is easy because it always makes first quadrant. So that's going to be 5, 13, 12. These guys, I'm pretty sure are all going to be Pythagorean triples just because of the algebra involved and stuff. Pretty sure we made these all Pythagorean triples. So the sine of x, -3/5. Cosine of y, 5/13. Big minus sign. Sine of y, 12/13. Cosine of x, 4/5. So we end up with -15 minus 48. And once again, see, these denominators are the same again, just like they were back in the old days. So we get -63/65. And just for the record, if the original problem had been cosecant, yada, 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 that would have made it -63/65. If the original problem had been cosecant. That's a big if, but I don't want to, probably shouldn't have written that. I don't want to confuse anybody. Sorry, that's the answer. Okay. Now this one says secant, so I'm thinking, uh-oh, I don't know what to do with secant. Yeah, you do. You're going to just do it as a cosine. You're going to say, oh yeah, cosine x plus y. You're going to treat it as a cosine to start out. So we're going to have cosine x, cosine y, minus sine x, sine y. Once again, though, we got to draw the triangles. So, oh, positive, that's nice. At least it's first quadrant. In negative sine, it's going to be fourth quadrant. So let me see. So I'm going to call this my x triangle. So cotan, that'd be 7, 24. That makes that a 25. Uh-oh, sine, we're in the fourth quadrant. So that's going to be -4, 5, +3. So cosine of x, 7/25. Cosine of y, 3/5. Minus sine of x, 24/25. Sine of y, -4/5. So 21 plus, what do we get there? 96/125. So what do we end up with here? Is that 117? Yay, 117/125. I hope that's right, because we all make mistakes with our arithmetic. 117. Okay, yay, I'm finished. Uh-oh, no, this was actually a secant problem. So I had to flip it over. It's actually a secant problem, so you have to flip it over at the end of the problem. Okay. Anyway, so these are what the problems on worksheet 512 look like. A little bit more complicated. Definitely a lot more labor intensive because you got to draw triangles on all these.